Hello, hi. Okay, in this video, I'm going to continue with our next subtopic, which is on our 1.5 computer level hierarchy. In this part, it is overview of computer level hierarchy. Computer consists of many beside chips. Before computer can do anything, it must also use software. So if you don't have software in your computer, it's not going to work. Maybe you cannot also open your computer, I guess so. Writing computer program require a divide and conquer approach, where each program module solve a smaller problem. Complex computer systems employ a similar technique through a series of virtual machine layers. So you basically will have altogether 7 layers, which is starting from layer 0 until your level 6. From level 0 to level 6. Altogether you have 7 layers. I think in our life there is more, about 7 layers. So it's easy for you to remember that everything, including our network layer, also have 7. Same goes to the computer layer, which is your virtual machine layers, also got 7. Starting from below, it is from layer 0, digital logic. Second layer is level 1, which is control. And then machine, system, software, assembly language, higher level language, and user. And in this our COA subject, we're going to look into this assembly language, which is the very basic language before you can learn higher level language like C++, Java, Fortran, and ish. There's a lot other Python, C programming, of course. So if you know the hierarchy on assembly language, it's easy for you to learn others language, including the higher level language. And you can see digital logic from beginning, I guess last semester you already take the digital logic subject, right? You learn on circuit, gates, and etc. This is my favorite subject because my background is from electronic. So I love playing with hardware rather than programming, which is software. I cannot see basically what they are doing in terms of programming, but of course in hardware I can see it and play around with the real life things. Okay, each virtual machine layer is an abstraction of level below it. So it's abstractions of the layer below it. The machines at each level execute their own particular instruction, calling upon machines at lower level to perform tasks as required. So if you don't have this layer, you cannot have the next layer. Computer circuit ultimately carry out the works. And each of this layer, there is also explanation. What you need to do is you need to memorize the functions and also the common terms, what is each layer are for. So this is a table commonly accepted layer in virtual machines. From our first higher levels, which is level 6, it called as a user level. This one is the one that you as a user can see. which is the program education and user interface level. The one that we can see the Windows, the iOS, Linux. So there is interface layer, program execution, whatever program you have in your computer, the level with which we are most familiar with. So this is the one that we always see. I guess so. Every single day you're going to use your computer, right? In next layer, which is level 5. In our level 5, it is higher level language. So in this level, we're going to play around with interact when we write a program, like in C, in Java, in Python, and etc. So it is in this level. And now for our COA subject, we are looking at this level 4, assembly language level, which is act upon assembly language produced from level 5 as well as instruction program directly at this level. For our level 3, which is system software level, it is needed for control as execution process on system, protect system resources. Assembly language instruction often pass through level 3 without modification. And afterwards, they're going to have level 2, machines or ISL level. In this level, it is consists of instruction. You can see over here instructions that are particular to the architecture of machines. Program writing in a machine language need no compiler, interpreter, or assembler. You can see over here, this is our second last level, which is level 1 under control level. So for control level, you can see over here, a control unit decodes and execute instructions and move data through the system. Control unit can be a microprogram or hardwired. A microprogram is a program written in a low-level language that is implemented by the hardware. Hardware control unit consists of hardware that directly execute machine's instructions. And our last layer, which is the one that I mentioned that I really love, is digital logic level layer, which is level 0. And in this, which is level with we find digital circuit, and then digital circuit consists of gates and wires. This component complements the mathematical logics of all the other levels. So that is on the computer level. And we have another 1.6. I guess I'm going to continue directly for this video. Let me check. Okay. It's only few. Let we see example system that available. Okay, you can see when you want to buy, that is a like this advertisement. You can see a lot of informations about this computer. And of course, before we want to buy the computer, we're going to look into several things, whether this is HDRM or SDRM. This one, I think, older versions. And then we're going to look into the RAM. Wow, Pentium, I don't want this computer. So this is the example of advertisement that available. So what is all this mean? Which is like LI, cache, PCI, megahertz, MB, USB. So if you know and you learn from COA subject, of course it's easy for you to handle to buy new laptop or new computer. Without having a handles on CHAS terminology, you will be hard pressed to know whether the stat system is wise by or even whether the system is able to serve your needs. So it depends on what job scope that you want to do. And this is a mathematical, I think, units, but you need to know and remember all these units. I guess we already learned it since our primary or secondary school. So hope that no need for me like to go too deep on this. And there is example on how to calculate the capacity and the speed from the advertisements. You can see we are given only like this, which is 1 megahertz. So what is basically 1 megahertz? You need to convert the units. Similar also on your byte normally is referred to unit of store, hertz for clock, cycle per seconds or frequency. And then in a millisecond, it is 1,000 of second. Nanosecond, what is the mini, which is time and space. So this is all example, only you can go through and take a look in your notes that are provided. And basically this is how you need to know about your computer, which is later you're going to go deeper, especially on like this RAM, which is random access memory. Later on you will see the ROM. Okay, so what is the acronym for ROM? And cache also. Normally we like, I want to clean my cache in my Google Chrome. There is a lot. So what is cache used for? And it is a type of temporary memory that can be accessed faster than your RAM. So RAM, which is your random access memory, means that memory content can be accessed directly if you know its location. I guess this part you can read it using your notes only. And there is several port that you basically can found in your computer, but sometimes you just use this port. But what is the name? So this is serial port, this is parallel port. So what is this parallel used for? I guess you can just like play and plug with like HTML port and parallel port. So in this COA subject, you just need to know, like in this figure, what is the name for this port, and this port, what is the name, because there is also a part A for you to answer a multiple choice. They give you like a picture only, then you just need to choose the correct name for several port. So you can go through what is the meaning of these advertisements. There is available in your notes. If you have any question and difficulty, we can also discuss in class later on. Please ask me, and you can WhatsApp me anytime that you want. And we can also have like session sharing together personally, okay? So as conclusion, the distinctions between computer organization and computer architecture is not clear-cut. In fact, neither computer organization nor computer architecture can stand alone. So there need of course to always correlation between each other. They are interrelated and interdependent. Students can truly understand each of these fields only after they comprehend both throughout the reminders of this course. So you need to have like module 3, module 4 because they are linked together. This leads to the deeper understanding of computers and computations, the heart and soul of computer science. I guess only that for this video. Meet you again in next video and in our class, of course. Okay, bye bye and please stay safe. Bye bye.